Hello everyone. In this video we will talk about the erythrocyte lifespan. You know that in the previous video we discussed the process of the erythropoiesis. This is the red bone marrow in which the red blood cells are formed. Red blood cells are formed inside the red bone marrow by the process of the erythropoiesis. The reticulocytes are produced. These reticulocytes will remain in red bone marrow about 2 days, and after that they will enter the circulation. Inside the circulation, the reticulocyte will be further converted into mature RBC after remaining about 1 to 2 days. During these 2 days, these reticulocytes will lose their remnant of mitochondria and Golgi apparatus. The mature RBC will now carry oxygen, and they will carry oxygen to different parts of our body. And after about 120 days in circulation, these RBC will become old, and these old RBC will be destroyed by cell of reticular endothelial system. The old RBC, as they lack nucleus, so they cannot form new protein. So this protein will get denaturation, and they cannot synthesize a new protein. This is the sibling. And the sibling is considered the most important part in which the red blood cell destruction occurs. Inside the sibling there is macrophage, which is known as splenic macrophage. This splenic macrophage will engulf these old RBC. And you know that these old RBC are formed by hemoglobin and also structural protein. The hemoglobin is formed by globin and heme. The globin and heme will further be degraded. And the globin part of hemoglobin is formed by amino acid, while heme part is formed by iron and porphyrin. These porphyrin will be converted into biliverdin and further into bilirubin. The conversion of porphyrin into biliverdin is done by the enzyme which is known as heme oxygenase, while biliverdin is converted into bilirubin by the enzyme biliverdin reductase. This is again the circulation, and this amino acid which form the globin will further be recycling to use by the bone marrow in the process of the erythropoiesis and produce red blood cell, while the iron will be bind to the transferrin and transported in circulation, which is by transferrin, and this iron will also be used in the process of the erythropoiesis, all it will be storage in the liver in form of ferritin. This is the unconjugated bilirubin, and this unconjugated bilirubin, which is water insoluble, and it is toxic substance, so it will bind to which known as bilirubin bind globin. The albumin is the most important bilirubin binding globin. This is the albumin, and which will bind to the bilirubin to form the unconjugated bilirubin. This is the liver. The unconjugated bilirubin will be uptake by hepatocyte. This unconjugated bilirubin, after uptake, it will be converted into conjugated bilirubin. And the process of conjugation is done by the enzyme, which is known as uridyl diphosphate glucuronyl transferase. We added glucuronic acid to the unconjugated bilirubin to become water soluble, which is known as direct bilirubin. and after that the conjugated bilirubin will be excreted into canalicular system, and it will flow in the hepatic duct, and both hepatic duct will unite to form the common hepatic duct, and the cystic duct will join the common hepatic duct to form the common bile duct. The common bile duct will open with the pancreatic duct into the second part of duodenum through the ampulla of Vata. This is the conjugated bilirubin which will reach the duodenum, and from the duodenum the conjugated bilirubin will reach the large bowel, and inside the large bowel the conjugated bilirubin will act by the bacterial gut. This bacterial gut will cleave the glucuronic acid through the enzyme which is known as glucuronidase enzyme, and converted conjugated bilirubin into urobilinogen. And urobilinogen, about 90% of it will be further converted into stercobilin, and stercobilin will be excreted in feces, which will give the yellow brown color to the feces. While the remaining 10% of urobilinogen will enter the portal circulation, which is known as enterohepatic recirculation. The urobilinogen will the urobilinogen when will enter the portal vein, it will reach the liver. About 5% of urobilinogen will enter the pathway of normal bilirubin metabolism, in which it will convert it into conjugated bilirubin and after that excreted in canalicular system, while the remaining 5% of urobilinogen will enter the systemic circulation, and from the systemic circulation it will reach the kidney, and through the kidney the urobilinogen will be excreted in urine. So the 5% of urobilinogen which will be excreted in urine give the yellow color to urine. I hope this makes sense. The pathway of red blood cell destruction and what are the fate of bilirubin. Thank you very much.